Hey everyone, this is going to go over the Unit 7 review sheet. Um, Hopefully it's a help. Let me know if you have any questions. All right, everyone, this is going to go over the Unit 7 review sheet. So number one, let X be a random variable representing the amount of sleep each adult in New York State got last night. Consider a sampling distribution of sample means X bar. So as the sample size becomes greater, what distribution does the X bar distribution approach? This is kind of like the central limit theorem, which basically states as any distribution, as the sample size becomes greater, it becomes the normal distribution. So this becomes the normal distribution. And again, that's our bell curve, mound-shaped symmetrical curve that we've been talking about. As the sample size becomes greater, what value will the mean of the X-bar distribution approach? As the sample size gets larger, so as the sample size approaches, let's say, infinity, then the X-bar distribution will approach the mean of the population. So you could also just write the mean of the population. Letter C, what will the standard deviation of the sampling distribution approach? So for letter C, with X-bar distribution, remember we had a different calculation for standard deviation. So the standard deviation of the sampling distribution isn't going to approach it's not going to approach the population standard deviation. It's going to approach that standard deviation divided by the square root of the sample size. So that kind of leads us to letter D. How would these two differ? The means would be the same. But let's see if this what will be different are their standard deviations. One will have a standard deviation of the standard deviation divided by the square root of 50. The other will have the standard deviation divided by the square root of 100. Okay, there's number one. Number two, the personnel office at a large electronics firm regularly schedules job interviews and maintains records of the interviews. From the past records, they have found that the length of a first interview is normally distributed with a mean of 35 minutes and a standard deviation of 7 minutes. What is the probability that a first interview will last 40 minutes or longer? So if we were to draw this out, here's the standard normal. The middle is our mu, which is 35. And we want to know 40 minutes or longer. So above that and up. So this is pretty much a calculator question. So if we take a look at the calculator, I'm going to do second verse, normal CDF. The lower is going to be 40. Upper is going to be 1E99. The mu was 35. The standard deviation was 7. And we get 0.238, let's say. So 0.238. Okay, for letter B of this question, it's asking 9 first interviews are usually scheduled per day. What is the probability that the average length of time for the 9 interviews will be 40 minutes or longer? So because we're dealing with 9 interviews, we're taking a sample from a population. We're going to change the standard deviation. So we're going to take the standard deviation, which is 7, and we're going to divide by the square root of the sample size, which is 9. So 7 divided by square root of 9 is 3. So now the standard deviation is about, let's say, 2.33. So if we go to our calculator, instead of 7, we're going to use 2.333, or you could type in 7/3 if you wanted to. In any case, So this gives us a probability of 0.016, let's say 0.016. 0.016. All right, number 3, assume that IQ scores are normally distributed with a standard deviation of 15 points and a mean of 100 points. If 100 people are chosen at random, what is the probability that the sample mean of IQ scores will not differ from the population mean by more than 2 points? So here's our mu, it's 100. Okay, and we're looking between 2 points, I shouldn't use the word variance, but 2 points above and 2 points below. So we're looking at 98 to 102. And because we're taking a sample of people, the sample mean, we have to have a different standard deviation. So in this case, our standard deviation for this sample is going to be the standard deviation divided by the number of people, the sample size, so the number of people we're choosing at random. So it's going to be 15 divided by the square root of 100. Excuse me. So that's going to be 15 divided by 10, which is 0. I'm sorry. No, not 0.15. 1.5. Sorry, 1.5. All right, so we go to our calculator. Oh, here, sorry, let me show you this. Lower 98, 102, 100, 1.5, and we get 0.818. Okay. Number 4, according to Harper's Index, about 11% of Americans believe that Joan of Arc was Noah's wife. She wasn't. At a large freshman meeting, a school counselor jokingly says that Joan of Arc was Noah's wife. Assume that freshmen are representative of the general American population regarding biblical knowledge. If the meeting was attended by 55 freshmen, what is the probability that up to 15% of the freshmen believe the counselor's claim? So here's our standard. Now the mu is 11%, and we want to know up to 15. So above that, so we're calculating this portion here. Right now, what we're going to have to do is and we're dealing with a proportion because it's a percentage here. So the P is 0.11, which means that the Q, the opposite of that, would be 0.89. So the mu would also be this 0.11. The standard deviation we're going to use, though, is the square root of PQ divided by N. So in this case, it's going to be the square root of 0.11 times 0.89 divided by 55. So that's going to give us square root divided by 55. A standard deviation of about 0.04. And then we should probably take into account, are we going to do continuity correction? Probably. So the continuity correction would be 0.5 divided by the 0.15. That doesn't seem... Oh, I divide by the wrong thing. 0.5 divided by 55. Sorry. Yeah, sorry. Not 0.15. We're supposed to divide by 55. That's the number of freshmen. Sorry. So our continuity correction is going to be, and I'm going to have to move 4b down. So I'm going to continue my work here. Continuity correction, I'm going to call that CC, is 0.01. So what I'm going to actually calculate on my calculator is the probability that x is less than or equal to, I'm going to add 0.01 onto the 0.15. So this is the 0.15. So I'm going to actually do less than or equal to 0.1, what did I say, 0.01, so 0.16. All right, so on my calculator, let's get rid of that. I'm going to do second vars 2. My lower is actually going to be negative 1 E99. My upper is going to be 0.16 with a mu of 0.11. The standard deviation, I forgot what I said, is 0.04. And that gives me 0.894. Right, so about an 89% chance that up to 15% of the freshmen believe that claim. All right, now 4B, I'll change color here. So I'm going to do 4B in red. What is the probability that between 10% and 15% of the freshmen believe the counselor's claim? So we're dealing with, here's 0.11. So we're dealing with 0.15 and then 0.10. So we're dealing with this portion of the graph. Right, the standard deviation will still be the same, 0.04. Our continuity correction will still be 0.01. So we're going to find the probability. So what I'm going to do is take the continuity correction. There we go. I'm going to add 0.01. I'm going to take away 0.01 from the left end. So I'm going to do 0.1 minus 0.01, which gives me 0.09. And then I'm going to add on 0.01 to 0.15 to get 0.16. And then I'm going to let the calculator do the rest of the work. So 2, the lower point, excuse me, I think I said 0.9. Yep. Upper 0.16, 0.11, 0.04. So the probability that it's in between is 0.586. So about a 58 to 59% chance that 10% to 15% of those freshmen believe that claim. All right, moving on to the last one. Maybe. All right, suppose we have a binomial distribution with n trials and a probability of success p. The random variable r is the number of successes in the n trials, and the random variable representing the proportion of successes p hat equals r divided by n. So 5a, if n equals 50 and p equals 0.22, we're going to compute 0.20 to 0.25. All right, so we need the standard deviation. The standard deviation, and this is dealing with p hat, so it's the square root of 0.22 times 0.78, all divided by 50. So that's going to give us a standard deviation of, all right, so square root 0.22. Now the 0.78 I got from doing 1 minus 0.22. So our standard deviation is about 0.06. All right, now if we want to do a continuity correction for this, we're going to do 0.5. And we're going to divide by, in this case, 50. So 0.5 divided by 50 is 0.01. So I'm going to subtract that from 0.20. So I'm going to make this 0.19. Now this is an x. And I'm going to add that onto the 0.25, so 0.26. And then it's calculator. So second verse, this I can put on here. Choice 2. The lower was 0.19, upper was 0.26. The mu was that point? 0.22. There was. Standard deviation was 0.06. So 0.4389. I guess I should say 0.4390. 0.4390. Okay, in the next one, n is 38, p is 0.27. That p hat will exceed. I think this is supposed to have a point here. So, oh no, I'm sorry, 35. I think it's supposed to have 0.35 here. So I think I made a typo. All right, so let's get our standard deviation is the square root of 0.27 times 0.73 out of 38. And the 0.73 I got, again, from doing 1 minus 0.27. So square root 0.27 times 0.73 divided by 38. So about 0.07. Continuity correction, I'm going to do 0.5 divided by 38 this time. So again, about 0.01. So that means will exceed. So the probability that x will be greater than or equal to 0.3. Now, actually, I'm going to make this 0.34 because greater than or equal to means that, again, maybe we can look at a picture here. I'll do it down here. If our mu is 0.27, 0.35 would be here, and we're looking for above that. So will exceed is up. So 0.35 is the left bound, the lower bound, so we're going to subtract that 0.01. So calculator. And verse 2, lower would be 0.34, upper 1e99. The mu was 0.27. Our standard deviation is 0.07, and so we get 0.158. If you want to see. All right, and then the last question on here is about, can we use the normal distribution to approximate this p hat distribution if n is 51 and p is 0.05? And technically we should have done this for the first two, but anyway, the reason, and this is a no, and here's why. Because if we do n times p, so 51 times 0.05, we get 2.55, which is less than 5. And for us to be able to use the normal distribution to approximate, NP has to be greater than 5 and NQ has to be greater than 5. And already NP is less than 5, so we cannot use that to approximate. All right, so hopefully that helps you out with those. Let me know if you have any questions. Hopefully right. We'll see you soon. Maybe.